hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad, as part of Data Mining video lecture series. In this lecture, we are going to discuss Introduction to the Frequent Pattern Growth Approach. Let us quickly see the outline of this presentation. In this, we are going to discuss mainly the cost of a priori, because we must and should understand why they have introduced the FP growth. Then we'll see the introduction to FP growth. There we mainly discuss how to construct the frequent pattern tree from the transactional database. So let us first understand what is the cost of a priori. The first one is it may still need to generate a huge number of candidate sets. Though we discussed different versions of a priori, like a partition, sampling, etc., but still need to generate a huge number of candidate sets. For example, if there are 10 to the power of 4 frequent one item sets, 10 to the power of 4 frequent one item set, that means if let us say, that is for easy understanding or simplicity, if a transaction has transactional database has only the 5 items A, B, C, D, E, so then these are the how many items? 5 items. Okay, so 2 to the power of 5 minus 1 item sets could be generated in this case. But if there are 10 to the power of 4 frequent one item sets, that means if suppose these are all the frequent item sets, frequent one item sets, because each item set has one items, like A, this is one item set, B and C, and so on and so forth. So the a priori algorithm will need to generate more than 10 to the power of 7 candidate 2 item sets. As we discussed, the level 1, it's a level, right? Test, right? Generate and test approach. So level 1 will generate the candidate item sets. And then we'll test, and then L2 test, and again we'll generate the candidate item sets and test like this. So this process need to be repeated till, that is this, till the last level. Let us say in this case, the previous lecture we discussed how many levels, like suppose the first level, that means one item sets, second level 2 item sets, third level 3 item sets, 4 item sets, and then 5 item sets, because there are 5 maximum number of items in the transactional database. So in this case, if there are, I don't know exactly how many item sets, how many items are there in this transactional database, but there are 10 to the power of 4 frequent. 10 to the power of 4 means 10,000 frequent one item sets. That means a level 1, there are 10 to the power of 4 frequent, that is a 10,000 frequent one item sets. So the a priori algorithm will need to generate more than next level, that is a 2 item sets, candidate item sets. These are not a frequent item sets yet, these are the potential item sets. So we have to determine whether these candidate 2 item sets are frequent or not, we have to scan the entire database. So then you can see here 10 to the power of 10, that means these many 1 crore item sets need to be generated, like as a candidate item sets. Then we have to find out the frequency, that is by scanning the entire database, we have to find out the frequency of each item set in this 1 crore 2 item sets. So then based on their frequency or the support, then we will check whether they are frequent item sets or not. So if you could imagine this, these many item sets need to be generated. Let us say for example, like suppose if you take, so for example, at this particular level level, let us say Li, that is at level I, there are 10 to the power of 7 two item sets. These are the frequent item sets. So then you could imagine, like suppose if you take like A, B, C, D, and there will be AB, AC, AD, BC, BD, like these are the possibilities. So you can see here how many item sets. Let us say AB, AC, 1, 2, 3, 4, 5 are like, so if there are 10 to the power of 7 item sets, 2 item sets are qualified as a frequent item sets, then you could imagine how many candidate item sets need to be generated at a Li plus 1 level, next level, that is 3 item sets. So that is the complexity, that is because it need to generate a huge number of candidate item sets. Second, it may need to repeatedly scan the whole database, like every time, like every level we have to generate the candidate item sets. Like first level we have to find out the frequency of each item set. If suppose there are 10,000 item sets, so for each item we have to calculate the frequency, that is by scanning the entire database. So that is one scan, like level 1. So one scan. Next, second level L2. So now we find the frequency of one item sets at level 1. Then we have to check based on the minimum support. If there are there are many frequent item sets, then we have to generate the candidate item sets from these frequent item sets. So again, in this, once you generate the candidate item sets at levels 2, then we have to do the scanning of entire database again to find out the frequency of these 2 item sets. And similarly, again we'll find out the frequent item sets, and then from those frequent item sets we'll generate the candidate item sets. Those are 3 items length. So this is the way, like each level, like based on the number of levels. Suppose there are n levels, n levels are used in this a priori, then n number of scans need to be done to determine the frequent item sets. So that is the another. It is costly to go over each transaction in the database to determine the support of the candidate item sets. So these are the two, the important costs need to be considered, still are not addressed by this a priori algorithm. So the researchers, they proposed another algorithm called as a frequent pattern growth, and in short FP growth. So because the objective of this proposing or developing this algorithm is to design a method that mines the complete set of frequent item sets without such a costly candidate generation process. If you could observe the in frequent item a priori frequent item set generation algorithm, the every level we have to generate a candidate item sets. So that is the costly process. So can we design a method that mines the complete set of frequent item sets without such a candidate generation process? Yes. So that is a frequent pattern growth. This is an algorithm where the candidate generation is not required. So FP growth adopts a divide and conquer strategy. First, it compresses the database representing the frequent item sets into a frequent pattern tree, or the FP tree, which retains the item set association information. It then divides the compressed database into a set of conditional databases. This is nothing but a special kind of a projected database, each associated with one frequent item or pattern fragment, and mines each database separately. For each pattern fragment, only its associated data sets need to be examined. Therefore, this approach may substantially reduce the size of the data set to be searched, along with the growth of the patterns being examined. So let us see how this frequent pattern growth could be applied and how it avoids the candidate generation process. So let us take the same transactional database that is from the textbook. It has 9 transactions like T with the transaction IDs T100 to T900 and the list of items I1, I2, I3, etc. Total 5 items in this transactional database. So now let us try to understand how do we construct the frequent pattern tree from this transactional database. So in this, the first step need to be done is that is the same as the step 1 or first step or step 1, that is we need to generate the one item frequent item sets. We have to generate frequent one item sets. This is the first step. One item frequent one item sets. This is one item sets. One item frequent item sets. So that is same as a priori, like we scan the entire database first beginning, then we'll find the frequency of each item. So let us say in this case, how many items in this transactional database? There are 5 items. So I1, I2, I3, I4, I5. So let us find the frequency of each item. Like let us say I1. So I1 frequency, that means in how many transactions the I1 is appeared. Like this is 1, the first transaction, second, third, fourth, fifth, sixth. So item 1 is appeared in a 6 transactions. Similarly, item 2. Let us find the frequency of item 2. So frequency of item 2, that is in this transaction 2, 3, 4, 5, 6, 7. So item 2 is appeared in the 7 transactions, and similarly I3 appeared in how many transactions? This is first transaction, second, third, fourth, fifth, sixth. So I3 is also appeared in a 6 transactions like I1. Then I4 in how many transactions it is appeared? 1, 2 transactions. It is appeared in 2 transactions. Then I5. So I5 is how many transactions it is appeared? Like I5 is appeared in first transaction and first, second. This is only 2 transactions. Only 2 transactions it is appeared. So that is the first we scan the entire database, then find the frequency of each one item set. Okay, individual frequency need to be calculated by scanning the entire database. This step is the same as in a priori. So then next, these items, these one item sets need to be sorted into the order. That is the order, that is frequency decreasing order, like the frequency decreasing order. So I2 will be the first. I will represent in this form of a set I2 first, then which is the item set which has the highest frequency, I1, that is 6, I3 6, then I4, then I5. Okay, so this is sorted item sets, ascending descending order. So now this is the first step. So then we have to construct a FP tree, frequent pattern tree. So before we construct, first let us start. We have to create a node with the null values. Null. Okay. We have to create a node null. Then we have to consider the transactions, that is the one by one, like first transaction. So in this first transaction, that is with the transaction ID, this is a transaction we are going to process now. So in this transaction has three items, I1, I2, I5. So now these items in this transaction need to be sorted into the need to be arranged in the same order, like this sorted ordering of one item sets as per the frequency descending. So as per that, I1, I2, I5 could be ordered like in this case. So which comes first? I2 comes first because I2's frequency is 7. Then next I1 comes, then I5. Okay. So this is after sorting. As per this, after sorting of this transaction 1 items, I1, I2, I5. So now we have to create nodes for I2, that is a frequency is 1, and then I1, its frequency is 1, then I5 frequency is 1. Okay, so this is the first transaction we process. Then second transaction, so here we have to create an index, that is to navigate this pattern, the frequent pattern tree. So it will be having the item, like suppose there are items like I1, I2, I3, I4 and I5 and their respective support count. And next the link, this is a node link, and this is the support. Okay, so now we have processed the first transaction, and the second transaction has two items, I2, I4. Now these items need to be ordered. So in this case, which comes first? I2, I4. So now we are going to add this transaction T2 items to this FP tree. So while adding this, if there is already path exists with the nodes, like the first node or the second node, then instead of creating the separate path, so what we will do here is we will consider this the same item, this path, and we'll follow this path, and instead of adding the one more item, we'll simply increase the support, the support count of the frequency of this item 2 by 1 or any item. So like suppose I2, I4. So from the root node we have to start, and there is a we have already created a node with I2. So then because it is matching with, so it is following the prefix, so then I2 could be incremented by 1. So let me update this. If it incremented by 1, it will becomes 2 here. It will become 2. Next I4. So there is no I4 along this path. So we need to create a separate node with the item I4, and its frequency is only 1. Okay. So now the second transaction also processed, and take the third transaction. So third transaction has two items, I2 and I3. So as per this order, so I2 should come first, then I3. So I2 again, because from the root node there is a path to the I2. Instead of creating the separate, we will increment this frequency, that is by 1. Then it will become 3. Then I3, there is no other, so we will create a separate node for I3, and its frequency would be 1. Next, the fourth transaction, that is this I1, I2, I4. Now we have to, before we add these items to this FP tree, we have to sort into the as per this order. So now the I2 comes first, then I1, then I4. So I2, I1, then I4. As per this order we have to construct. So now I2 again, so then I will increment this frequency by 1, it will become 4. Then I1, now this is the path we have to follow. Then previously I frequency is 1, it will be incremented by 1, so it will become 2. Then I4. So here there is no item set from this. So here I will connect this. I will create a new node. Then I'll put this frequency and this I can link it. Okay. So or we can, okay. So this is the way we will create a frequent pattern trees. Like for example, if you take the next transaction, that is I1, I3. So there is no route from the, there is no path to the node I from this route. So then we have to create I1 with frequency and then I3. Okay. So this is the way we'll construct the frequent pattern tree. So next lecture we'll see how a set of frequent patterns or frequent item sets would be mined from this frequent pattern tree. Thank you for watching.